So let's simplify this expression. Well, looking at our expression, we have a rational expression divided by a polynomial. Well, since we're taking a fraction divided by something that's not a fraction, it'd be easier if we had it even. So in our first step, let's rewrite the second part of our expression as a fraction. So let's turn this polynomial into a fraction. In other words, let's just put it over 1. So now we have 2x squared plus 3x minus 5 over 1. We now have a fraction divided by another fraction. Well, if we're taking a fraction divided by another fraction, it's a lot easier to change it to multiplication. So in our second step, let's change this problem to multiplication by multiplying by the reciprocal of our second fraction. To do this, we rewrite our first rational expression, and then we change our division sign to a multiplication sign, then multiply by the reciprocal of our second fraction. So, we have 1 in the numerator and our original polynomial in the denominator. Now we have a fraction times a fraction. Let's multiply these two fractions together. So we multiply the numerators together, and then we multiply the denominators together. Now when you're doing this step, you might be tempted to multiply the two trinomials in the denominator together. We'll hold off on that temptation because it will be a lot easier if we were to factor these polynomials instead of multiplying them together. So in our next step, once we have everything in one big fraction, let's take each polynomial and factor it into its lowest terms. So in step number 3, we'll factor the numerator and denominator. When we do, our polynomial in the numerator will become 2x plus 5 times x minus 3. Then in the denominator, we want to factor each polynomial separately. This polynomial will factor into x minus 3 times x plus 1. Now when we factor our second polynomial, we get 2x plus 5 times x minus 1. Great. Now we've taken each polynomial and factored it into its lowest terms. In our next step, let's look at canceling out common factors in the numerator and the denominator. So starting in our numerator, we have 2x plus 5. Well, is there a 2x plus 5 in the denominator that we can cancel that out with? Yes, there is. There's a 2x plus 5 in the numerator and the denominator, so we cancel those terms out. Now x minus 3. Well, there's an x minus 3 in the denominator as well, so we can cancel out those binomials. Now, we're out of terms in the numerator, so we're done canceling. In our next step, we want to multiply everything back together that's left in our numerator and denominator. This will give us our answer. So starting in our numerator, we canceled everything that was in our numerator, so we just have a 1. In the denominator, we have an x plus 1 left, and we also have an x minus 1. Well, if we want to simplify this, we have a sum and a difference being multiplied together in the denominator. This is a difference of squares problem. Using the difference of squares, we can multiply those two binomials together to get x squared minus 1. So now we have our answer. We took our original problem and simplified it to 1 over x squared minus 1.